This is Professor Deref Seitz, Laws of Radicals. The assumptions in these laws is that for even roots, and here indicating the roots that you'll see the indexes on the radicals, for even roots, the radicands, those are the things underneath the radical sign, A and B in these examples, are non-negative. And as always, denominators are non-zero. This denominator here, B, has to be non-zero. The first rule is the product rule. The nth root of a product, A times B, is the same as the product of the nth root of each factor, nth root of A times the nth root of B. This can be used to simplify radicals. The square root of 20, we can factor 20 as 4 times 5. It's the square root of 4 times 5. Why 4? Because 4 is a perfect square. It's 2 squared. Using the product rule, we split it apart, break it out. Square root of 4 times the square root of 5. And the square root of 4 is 2 times the square root of 5. A simplified form of the square root of 20. The quotient rule. The nth root of a quotient A over B is equal to the nth root of the numerator divided by the nth root of the denominator. Nth root of A divided by the nth root of B. An example, the square root of the fraction 144 over 49 is the same as the square root of 144 divided by the square root of 49. And these are both perfect squares. That's 12 divided by 7. Power of same root. We have a power n and we have a root n. So the nth root of A and then taking it to the nth power. These are inverse operations and they undo each other and you end up with A. An example, the square root of 5, the implied index on a square root is 2, squared is 5. Similarly, we have the root of the same power. Here, the nth root of A to the n, with the exponent being under the radical sign. Again, these are inverse operations and you get A. Example here, the square root of 5 squared is 5. Let's look at this example where we have the radicand is negative because we have an odd root, an odd index. That's okay. It's only for even roots that you have to have non-negative radicands. Cube root of negative 8 is the same as the cube root of negative 2 cubed. Negative 2 times itself 3 times. Negative 2 times negative 2 is positive 4 times negative 2 again is negative 8. And so the cube root of negative 8 is negative 2, but we can see this rule showing this here. These 3's effectively inverse operations cancel each other out and you end up with a negative 2. Finally, to convert between radicals and fractional exponents. The nth root of A to the m is the same as the nth root of A, that whole thing to the mth power. Either one of those radicals can be converted to a fractional exponent, A to the m over n, where the root becomes the denominator and the exponent becomes the numerator of the fraction. Let's look at an example here. The cube root of 2 to the 6th power can be rewritten as 2 to the 6 over 3. That's 2 squared or 4. An alternative way would be to take the 2 to the 6 and multiply it out. 2 times itself 6 times, and you have the cube root of 64. And then to know that 4 cubed is 64. 4 times 4, 16 times 4, 64. So alternate ways, but it's very efficient to sometimes convert to fractional exponents and simplify from there.